Dear students, welcome back. This is my 12th lecture on carbonyl compounds. In this lecture, I will explain to you alpha substitution reaction, halogenation of enolizable aldehydes and ketones. In the next lecture, I will explain to you Michael addition. Myself, Rakesh Singh, Associate Professor in Chemistry, Government Degree College, Kathua, Union Territory of Jammu and Kashmir. Let us proceed. First slide. Alpha substitution reactions, halogenation of enolizable aldehydes and ketones. Aldehydes and ketones which contain alpha hydrogen atom undergo tautomerism to form enols and hence are called enolizable aldehydes and ketones. ये देखें बच्चे, aldehydes and ketones which contain hydrogen atom on alpha carbon. This is alpha carbon. This carbon atom attached to the carbonyl group is alpha carbon, and the hydrogen atom attached to it is called as alpha hydrogen atom. So the alpha hydrogen atom can enolize and form the enol form like this. That is why we call them enolizable aldehydes and ketones. Those aldehydes and ketones which contain alpha hydrogen atom, that is alpha hydrogen with respect to carbonyl group, they can enolize and hence we call them enolizable aldehydes and ketones. This is enol form. Usually enol form is less stable than the oxo form, carbonyl form, because of the repulsion of lone pair to the pi. Okay. So when we treat such aldehydes and ketones with halogen, जब हम ऐसे aldehydes या ketones को which contain alpha hydrogen with halogen in presence of acid or base, what happens? The alpha hydrogen atoms get replaced by halogen, and we get alpha halo aldehydes or alpha halo ketones. It can be aldehyde, it can be ketone, depending upon the value of R here. It can be H, it can be alkyl. Alpha halogenation can be induced by acid as well as base. Acid-induced halogenation stops after introduction of one halogen, whereas base-induced halogenation proceeds further till all the alpha hydrogens get substituted by halogen atom. Let us explain in detail. Acid catalyzed alpha halogenation stops at monohalogenation, whereas base-induced alpha halogenation of enolizable ketones goes on till all alpha hydrogen atoms get substituted by the halogen. Let us proceed further. First, base promoted halogenation and its mechanism. Now, this is acetone, this is alpha carbon, and these are alpha hydrogen atoms. When we treat this enolizable ketone with halogen in presence of base, OH negative, what happens? The alpha hydrogen atom get replaced by halogen, alpha substitution. Again, the next, we have 3 alpha hydrogen atoms. All the 3 get replaced one by one. And we get 1,1,1 tribromopropane 2. 1,1,1 tribromopropane 2. The reaction starts with abstraction of acidic alpha hydrogen atom by base. मैकेनिज्म में हम दिखाएंगे इसको डिटेल में. मुझे ये जो हम Cl2 अंडरस्टूड है, ये ऐसे है क्योंकि पीपीटी में थोड़ी प्रॉब्लम आती है लिखने में, कि पीपीटी में सब्सक्रिप्ट नहीं होता. ये मैंने कैमड्रा में ड्रा की है, तो यहाँ तो हम ड्रा कर सकते हैं आसानी से. तो नेक्स्ट वी हैव द मैकेनिज्म. एक पॉइंट यहाँ पे नोट करने वाला है. I have done the alpha halogenation in case of acetone. Acetone has alpha hydrogens on both sides, but I have done alpha halogenation only on one side. इसका भी reason मैं आपको बताऊंगा. Why not on the other side? I will explain to you. So let us first see the mechanism. It is base induced. What happens? As you know, the alpha hydrogen atoms of the aldehyde and ketones are acidic in nature. So base removes alpha hydrogen, which is acidic, and form carbonyl. The carbonyl is resonance stabilized. It form the enol ion. The enol ion मैंने जैसे पहले बताया आपको, enol form is less stable because this negative charge will repel back the pi electron cloud, and when it move back, enol form tries to move back to the carbonyl form, keto form. It is called keto-enol tautomerism. When it moves back, this pi electron attack on the halogen. Halogen will be polarized by it itself into partial positive and partial negative. Polarization ये खुद कर देगा जब halogen इसके पास से move करेगा due to repulsions, so it will attack it. What do we get? We get alpha bromoacetone. Alpha bromoacetone. This is how base induced halogenation, alpha halogenation occurs. First, OH negative removes alpha hydrogen atom, form the carbonyl, which is resonance stabilized. This is enolate ion. Enolate ion then tries to return back to the keto form. This form, when it return back, what will happen? CH2 negative, negative will attack on bromine, and there will be substitution. Minus आप यहाँ लिख सकते हैं Br, नेगेटिव ने अटैक करना पॉजिटिव, तो माइनस क्या हो गया बच्चे? Br नेगेटिव बाहर निकल गया. Similarly, other two halogen atoms from the same carbon atom get replaced by halogen atom. This is because minus I effect of halogen makes alpha hydrogen of alpha haloketone more acidic. Halogen के आने से ये hydrogen और acidic हो गए. Now OH negative can easily attack on it. One by one, all the three hydrogen atoms get replaced. एक एक करके सारे हाइड्रोजन एटम क्या हो जाएंगे? रिप्लेस. OH नेगेटिव H को निकालेगा और C नेगेटिव Br ब्रोमीन के ऊपर अटैक करेगा, एंड वी गेट ट्राई ब्रोमो सब्स्टिट्यूट, अल्फा 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 ट्राई ब्रोमो एसीटोन. अब आपके दिमाग में एक क्वेश्चन आएगा कि ये जो बना, इसने दूसरी साइड जो अदर साइड ऑफ द एसीटोन है, it also possesses alpha hydrogen. Why those alpha hydrogen atoms were not replaced by halogen? The reason is obvious. When this is formed, before it can undergo substitution on the other side, it get attacked by the OH negative. Why? Because of presence of these three halogens, this carbon bond become highly polarized, and this carbon acquires sufficient amount of positive. It get easily attacked by this, and the bond. C negative ले लेगा H positive, we get bromo form. If it is iodine, we get iodo form. If it is chlorine, we get chloroform, along with formation of carboxylic. As we are using base, we will get sodium salt of acid. This is the reason why halogenation on other side does not occur. Haloform reaction. So 1,1,1 trihaloalkanes जो अभी हमने बनाया होगा are not stable under basic conditions of reaction and hence are readily hydrolyzed to give carboxylic acid with one carbon atom less than the parent ketone. Act. Strong minus I effect is operating, which make this bond highly polar, carbon-carbon, because of three electron withdrawing groups attached to carbon, and this carbon has sufficient positive charge, so it gets easily attacked by the OH negative and hydrolyzed. बनेगा क्या? देखा जाए आपके दिमाग में आएगा CH3COOH बनना. You will say OH अटैक कर रहा है C के ऊपर. What याद रखें, in presence of base acid forms. वी गेट एक्चुअली आप सोचेंगे ये बनना चाहिए, मैं आपको दिखा देता हूं, आई विल शो यू C negative Na positive as per this reaction. C negative Na positive OH should go to C, but you know carboxylate ion CH3COO negative ion is more stable than C negative ion. This ion, carbonyl ion, this is more stable because it is ion stabilized. Mean acid will form salt more easily than carbonyl. There will be exchange between two, and we will get what? CH Br3 plus sodium salt of acid. याद रखें बच्चे, जब भी कहीं पे बेस और एसिड बन रहा हो, you will not get the acid, you will get the sodium salt of that when you are using the base in reaction, as in this case also. Previously हमने काफी इस टाइप के कंपाउंड्स पढ़े जिसमें हमने बेस का इस्तेमाल किया और एंड में एसिड बन रहा था, we formed the salt of acid. Now this reaction is called as haloform reaction, क्योंकि इसमें haloform बनता है. In case of chlorine, chloroform; in case of bromine, bromoform; in case of iodine, iodine. CHI. आइडोफॉर्म जेलो कलर्ड प्रेसिपिटेट होते. आइडोफॉर्म टेस्ट को हम यूज कर सकते, याद रखें बच्चे, हमने पहले भी इसको डिस्कस किया आइडोफॉर्म टेस्ट को, यहां मैं फिर बताना चाहूंगा. एनी कंपाउंड विच कंटेन दिस ग्रुप, आपने देखा अल्फा हाइड्रोजन, अगर 3 अल्फा हाइड्रोजन एटम होंगे, एनी कंपाउंड विच कंटेन दिस ग्रुप एंड ट्रीटेड विद हैलोजन in presence of NaOH, it will form haloform like this. इस साइड कोई भी लगा हो डजंट मैटर, जैसे यहाँ मिथाइल लगा है डजंट मैटर, एक साइड H होने चाहिए 3, जिसकी जगह ये ब्रोमीन आए. दूसरी साइड on the second side, other side we may have alkyl or hydrogen. So all those compounds which contain CH3CO group when treated with iodine in presence of alkali, they form idoform, yellow colored precipitates. So this reaction can be used for identification of this group in our running compound. कल को आपसे कोई कहे कि CH3CO ग्रुप को आइडेंटिफाई करना हो कि कंपाउंड में है या नहीं, तो विच टेस्ट कैन बी यूज्ड? आइडोफॉर्म टेस्ट. क्लोरोफॉर्म ब्रोमोफॉर्म की बात नहीं करेंगे क्योंकि कलर ये है, कलर से पता चल जाएगा. आइडोफॉर्म येलो कलर प्रेसिपिटेट बनेंगे, यू कैन से आइडोफॉर्म बनना, इट मीन द कंपाउंड मस्ट हैव दिस. अगर आप प्रीवियस स्लाइड को देखें तो उसमें ये ग्रुप था. If you see the previous slide, बच्चे देखिए, this was the group. यहां से स्टार्ट किए ना, दूसरी साइड कुछ भी होगा चलेगा, but one side we should have 3 alpha hydrogen atoms, CH3CO. This part should be here. Alpha halogenation of unsymmetrical ketone. अगर unsymmetrical ketone है, unsymmetrical मतलब एक साइड देखें मिथिलीन लगा है, एक साइड मिथाइल, क्वेश्चन राइज होता है which side will be preferred for halogenation. Answer is clear. In this, base is attacking on acidic hydrogen, so base will prefer that hydrogen which is more acidic. This side we have alkyl group which is electron releasing, so this methylene part is less acidic. These hydrogens are less acidic than methyl, and therefore halogenation will occur on methyl side. Halogenation of unsymmetrical ketones, missing here, occurs at methyl rather than methylene. Methyl rather than methylene. This is because plus side effect of the alkyl group makes alpha hydrogen of methylene group less acidic. तो आप देखिए बच्चे, इसमें हमने हेलोजिनेशन किस साइड किया? मिथाइल साइड. अनसिमेट्रिकल कीटोन, अनसिमेट्रिकल कीटोन. नेक्स्ट स्टेप में इसकी हाइड्रोलिसिस होनी, वो तो होनी है, NaOH और ब्रोमो फॉर्म बनना है. नेक्स्ट, acid catalyzed halogenation. Acid catalyzed halogenation differs from base catalyzed halogenation in the respect that base induced halogenation in the respect that The halogenation in case of acid catalyzed process stops at monohalogenation stage. After monohalogenation, it stops. Question arises by. ऐसा क्यों होता है? उसका रीजन हम देते हैं, आंसर देते हैं. Mechanism of acid catalyzed alpha halogenation. Let us see the mechanism, then we will get the answer. Monohalogenation, तो आपको understand हो गया. Only one alpha hydrogen atom get replaced. This is the mechanism. In this case, we are using acid. Acid क्या कर सकता है? Acid तो H positive को नहीं ना निकाल सकता, वो खुद acid है. It will cause the protonation of oxygen of the carbonyl group. ये उसकी protonation कर देगा. Due to protonation, the ketone or aldehyde will get converted into enol form. ये हमारी enol form बन गई. But enols are less stable. You know it better. I have explained to you because lone pair pi electron repel. Lone pairs are loosely held. Pi electron, pi bond is a weak bond. Occupy more space. So there will be repulsions. So when it return back to this form, which form? कौन सी form? When it return back to oxo form, keto form, this CH2 negative attack on bromine. CH2 negative. यहाँ पे इनोल फॉर्म जब वापस ऑक्सो फॉर्म में जाने की कोशिश कर रही है तो CH2 नेगेटिव बन रहा है. जो प्रीवियस हमने किया उसमें CH2 नेगेटिव क्यों बन रहा है? बिकॉज OH नेगेटिव इज abstracting H positive. Here H positive is protonating O, giving this we are getting the enol form. हमें enol form मिल रही है और जो enol form है then here we should have enol form. We should have this arrow. This is not resonance structure. We should have this arrow. This arrow is used for resonance. Not resonance structure. This is automerism minus H positive. Acid catalyzed automerism. We get enol form. When enol form return back to the keto form, we try to return back to the keto form. What happened? CH2 negative is formed. CH2 negative will attack on halogen. The positive pole of bromine, positive, and we get monohalogenated product. The next step it will lose H positive and we get final monohalogenated product. Question राइज होता है कि monohalogenation होने के बाद further substitution क्यों बंद होगी? Answer is simple. Due to attachment of bromine, minus I effect is exerted on the carbonyl, due to which electron availability on oxygen decreases. Minus I effect of the halogen decreases the availability of lone pair on oxygen, due to which protonation is difficult to occur, and hence what happens? Further halogenation stops. Protonation से start हुआ देखिए आप. Further halogenation stops because minus I effect of halogen decreases availability of electron oxygen of carbonyl group and thus makes protonation. इसमें याद रखिए बच्चे, इसमें इनोल बनता. सबसे पहले क्या बनना है इसमें? इनोल प्रोटोनेशन से, और फिर जब इनोल वापस कीटो फॉर्म में जाएगा CH2 नेगेटिव जो बनेगा, that will attack on bromine and we get monohalogenated. Next, halogenation of unsymmetrical ketones. अगर आपका कीटोन अनसिमेट्रिकल हो तो हेलोजिनेशन कौन से पार्ट पे हो? जैसे फॉर एग्जांपल वी हैव टेकन दिस अनसिमेट्रिकल कीटोन, which side will be halogenated? Acid catalyzed halogenation preferably occurs at methylene group. This is in contrast to what? Base catalyzed, base induced halogenation. This is because in this case, the rate determining step is formation of enol. And enol from the side of methylene will be more stable than from the side of methyl. Why? Because more substituted alkene, more it is stable. This is more stable, this is less stable. And hence, the product will be formed which is formed from more stable enol. As enol 1 is more stable than enol 2 due to hyperconjugation, इसमें ज्यादा ग्रुप लगे हैं बच्चे, आपके सामने है, इसमें एक ही साइड मिथाइल है अल्कीन के ऊपर, so this alkene is more stable, this enol is more stable, since enol 1 is more stable than enol 2 and hence the reaction can be written as, याद रखिए बच्चे कि in case of unsymmetrical ketones in acid catalyzed halogenation, the halogenation preferably occurs at methylene group rather than methyl. This is in contrast to base induced halogenation. This enol is more stable and we get this monohalogenated. Thank you very much. This is my WhatsApp number. If you have any doubt regarding this video lecture, you can call me, you can WhatsApp me. Thank you very much.